So now let's see how we can implement some resiliency in our microservice architecture. So let's assume we have a booking service that goes down or it has some kind of issues connected to the DB server. API Gateway is still going to be accepting requests and it will try to send these requests to booking service and wait for a response. But because booking service is not in a healthy state, API Gateway is never going to be getting a response back and booking service will simply be overloaded with requests. Same thing goes for inventory service. Or something similar could even happen in this request here, the request number 5. Order service could be calling inventory service to update the inventory. But for some reason, inventory service could be down and it will simply be overloaded with requests. In this case, we can implement a pattern which is called the circuit breaker pattern. This is how it would look like. We are going to be using Resilience4J as the circuit breaker pattern implementation library. And what will happen is if booking service is failing to respond within certain set thresholds, our circuit breaker is going to stop all requests going from API Gateway to booking service. And we can define some parameters to allow some requests to go through even when they are failing, just to make sure that booking service is still unhealthy. And if we do get a response back, we will send it back to our client. And then the circuit breaker will be going back in a closed position. So let me explain it a bit better. A circuit breaker can have 3 states: a closed, open or half open. When the circuit breaker is in a closed position, everything is good, requests are going through. But let's say some requests fail and this failure is greater than the threshold we've set up. The circuit breaker will move to an open state, and in this open state, it will be stopping requests going to the downstream service. After a certain threshold, it will move to half open. In this half-open state, we will let few requests go through to our downstream service. And that's to determine if that service is back up again. If not, we will go back to an open position and we will start throttling the requests. But once the failure rate is below a certain threshold, we will move our circuit breaker in a closed position and all the requests will flow as normally. So these are the 3 main states. Let me show you what we will be using to implement this pattern. We will be using Resilience4J. It's a lightweight library that is designed for this specific purpose. It also offers other patterns such as rate limiter, retries, or bulkhead. The one we are interested in is the circuit breaker. So let's go back to our API gateway and we need to add a couple of dependencies. So if you go to pom.xml, let's add a new dependency. And we want to add Spring Cloud, Starter, Circuit Breaker, Resilience4J, and this is from the org.springframework.cloud. And the second dependency we want to add is Spring Boot, Starter, Actuator, and this is from org.springframework.boot. This second one is used to track the status of health endpoints and find the health of the circuit breaker. It will be clearer in a bit, I'll just show you. So let's import these dependencies and let's go to our application.properties. We need to add a number of properties, so instead of me just typing, I'm just going to copy and paste and we'll go through these properties. So we will need all of these. So we need these 3 properties for our actuator. We want to enable the health endpoint for the circuit breakers. We want to do this for all the endpoints and we want to show the details always. The next bunch of properties is specific to Resilience4J. We're going to be using a sliding window of type count to check our thresholds. We're going to set the size of our sliding window. We will be checking 8 requests at a time and we want to set a failure threshold. So in this case, it's 50%. So if 50% of these 8 requests fail, we will be moving our circuit breaker from a closed position to an open position. We also want to set up a minimum number of calls because as soon as we reach 4 calls, we want to see if the first 4 calls are failing, we want to activate our circuit breaker. We don't want to wait for all 8 of them to fail. We want to set up a duration in the open state. If our circuit breaker activates, we want it to stay in an open state for at least 5 seconds. We also want to allow some requests to go through when we are in half open state. In this case, I've set up 2. And we also want to automatically transition from open half to open enable state. So we want to set this to true. We can also add some timeout limits, in this case 3 seconds, and we can define some maximum attempts with a minimum wait duration between these 3 attempts. This is all we need in our application.properties. Now we can simply go in our booking service routes and let's add a filter. This is going to be using a circuit breaker filter function, and we're going to define a name for this. I called it booking service circuit breaker. And when this circuit breaker activates, we want to forward this request to this endpoint. But we don't have this endpoint yet, so let's create a new bean. And this bean will be handling with all of our failure requests. Let's just call it fallback route. And this fallback route will be called when the circuit breaker is activated. And we want to return a message saying booking service is down. This is all we need to implement a circuit breaker. Let me show you the circuit breaker in action. So make sure inventory service is running. Do not run booking service for now, so I'm going to stop it. Also, let's have order service running. I assume that all of the services in Docker Compose are running. So the last service to run is our API gateway. So let's run this. This has started successfully. So let's go to Postman and let's check the actuator health endpoint to see the status of our circuit breaker. So we need to generate a new access token. Let's send a request. And our circuit breaker is in a closed state at the moment. So this is good. It means the requests are going through. Now let's go back to our post request to send a booking. Let's generate a new token and let's send a request. So if we send 1, 2, 3, I've sent 3 requests. This should still be in open state, in closed state. And that's because we have not reached the threshold yet. If I go back to booking, I send few more requests. As soon as it goes above 4 requests failing, our circuit breaker already went into a half open state. Now, if we send a couple more requests, let's check back. Our circuit breaker is back into open state. Let's send a few more. Still in open. And now it's half open because after 5 seconds from open it goes to half open to allow some requests to go to the downstream service. Let's go to our booking service. Let's start it up. And let's send some requests now. So when I send 1 request, this has gone through. Let's check our circuit breaker is still half open. So let's send 2 more requests. Let's check the health. And now our circuit breaker is in a closed state because our booking service is back up healthy. And because we have also added timeout durations, what this means is if an endpoint times out for more than 3 seconds, it's going to be considered as a failure. So you can also do that test. You can simply add some kind of wait in the booking service endpoint. And when that wait will be triggered, the circuit breaker is going to get activated. What we have just seen is a nice and easy way to protect our system from overloading when one of the services is down. If booking service is down, it will stop getting requests for no reason because it's not able to process them. And once it's back up again, it will be able to keep processing requests coming from the API gateway. But up until this is not healthy again, our circuit breaker is going to be acting as a valve and it's going to stop requests from overloading our downstream service that is already struggling. The last step of our video is to create some API documentation.